हेलो स्टूडेंट्स, इस वीडियो में हम एक्सरसाइज 1.1 के क्वेश्चन नंबर 4 एंड 5 डिस्कस करेंगे। क्वेश्चन नंबर 4 कुछ इस प्रकार है। यूज यूक्लिड्स डिवीजन लेमा टू शो दैट द स्क्वायर ऑफ एनी पॉजिटिव इंटीजर इज आइदर ऑफ द फॉर्म 3m और 3m plus 1 फॉर सम इंटीजर m. Let us proceed. Let a be any positive integer and b is equal to 3. Be another integer which is already positive. Assuming that a is greater than 3, then by Euclid's division lemma, we have a is equal to 3q plus r, where q is the quotient, r is the remainder when a is divided by 3. R will be less than 3 and greater than or equal to 0. Thus, the structure of A may be A is equal to 3q plus 0 or 3q plus 1 or 3q plus 2. The structure of A may be either 3q plus 0 or 3q plus 1 or 3q plus 2. So, here 3 cases arises. Case first, suppose A is of the form 3q plus 0 or 3q. Squaring both sides, we have what we have. A is equal to 3q square is equal to 9q square. Taking 3 common, we get this, which can be written as 3m for some m, where m is equal to 3q square, a new integer. Case 2. A is equal to 3q plus 1. Squaring both sides, we have a square is equal to 3q plus 1 whole square. Using the identity a plus b whole square, we have 9q square plus 6q plus 1, which can be expressed as by taking 3 common, 3q square plus 2q plus 1, which can be written as 3m plus 1, where we have taken 3q square plus 2q as m. Case third, let A be equal to 3q plus 2. Again squaring both sides, we get a square is equal to 3q plus 2 whole square. Applying the identity of a plus b whole square, we get 9q square plus 3 2 ja 6, 2 ja 12q plus 2 2 ja 4, which can be expressed as 9q square plus 12q plus 3 plus 1, because we have to make the structure of the result as either 3m or 3m plus 1. Take 3 common, we get 3q square plus 4q plus 1 plus 1. We can write it as 3m plus 1, where m is 3q square plus 4q plus 1, a new integer. Thus, we observe that in all the three cases, from the above three cases, it is proved that the square of any positive integer is either of the form 3m or 3m plus 1 for some integer m. Here we have taken b as 3 because we have to make the structure 3m or 3m plus 1. Thank you, guys. Now taking the question number 5. What is this question? Use Euclid's division lemma to show that cube of any positive integer is of the form 9m or 9m plus 1 or 9m plus 8. We will prove it in the same way as the question number 4. Let's proceed. Let A be any positive integer and b is equal to 3. We can take 3 or 9. We have taken here 3 as 3 is the factor of 9. Be another integer supposing that a is greater than 3, then by Euclid's division lemma, we have the structure of A as 3q plus r, where q is the quotient and r is the remainder when A is divided by 3. And r will be less than 3 or greater than or equal to 0. That is, the form of A can be 3q plus 0, 3q plus 1 or 3q plus 2. Let us assume that the form of A is 3q. Then cubing both sides, we get 27 cube. Since we have to make the structure of A cube as 9m or 9m plus 1 or 9m plus 8, so we take here 9 as common, which can be written as 3m, where we have taken 3q cube as m, a new integer. Case 2. Let A is equal to 3q plus 1. Again cubing both sides, we get A cube means 27q cube plus 3a square b means 27q square plus 3ab square means 9q plus bq means 1. By taking 9 common, we have 27 3q cube plus 3q square plus q plus 1, which can be expressed as 3m plus 1, where we have taken m as 3q cube plus 3q square plus q. Case 3. Let A is equal to 3q plus 2. Again cubing both sides, we get 27q cube plus 54q square plus 36q plus 8 using the identity of a plus b whole cube, which can be written by taking 9 common as 3q cube, 6q square plus 4q plus 8 or 9m plus 8, where 3q cube plus 6q square plus 4q is equal to m. Thus, from the above 3 cases, it is clear that cube of any positive integer is of the form 9m or 9m plus 1 or 9m plus 8 proved. Thank you.